Hello and welcome to problem set 33. Today we are going to talk about all sorts of polygons and see their different and specific properties. So first off, we're going to start with the quadrilateral. It's pretty easy to figure out what this shape is. Quad means four, lateral means side. So these are four-sided figures. Now, within quadrilaterals, we find a bunch of other different shapes. One of those shapes is a parallelogram. And I would encourage you to take notes on this. A parallelogram has some specific properties that you need to know. Number one, it has two sets of parallel sides. Secondly, both pairs of opposite angles are congruent. Third, diagonals bisect each other perfectly. That means they chop each other in half. And fourth, any pair of consecutive angles is supplementary. So let's take a look at a parallelogram. If we take two parallel lines and another two parallel lines, we have formed a parallelogram. So what am I saying with these properties listed here? I'm saying that, number one, it has two sets of parallel sides. These two and these two. Next, pairs of opposite angles are congruent. So that means that this angle equals this angle. And this angle equals this angle. That's this guy right here. Next, I said that diagonals bisect each other. That means if I take from this point to this point, and this point to this point, these two distances are the same. And these two distances are the same. They're perfectly bisected. Finally, consecutive angles are supplementary, means that this angle plus this angle add up to 180 degrees. Does that make sense? Of course it does, because this angle is the same as that one. And both of those add up to 180 degrees. So you should know these four properties of a parallelogram when looking at your proofs problems. Now, let's go a little bit more specific and look at a particular type of parallelogram. Again, all of the same properties of a parallelogram will apply, but we are adding more to that. So let's talk about this shape called a rectangle. So the rectangle, as we know it, is a shape with four right angles. Additionally, it has all of the properties of a parallelogram, which means that it has two sets of parallel sides. These two angles are the same. These two angles are the same. And your diagonals bisect each other. Finally, these two angles, or any two angles that are next to each other, add up to 180. So, a rectangle has four right angles in addition to all the parallelogram properties. Finally, the diagonals are congruent. What that means is that this distance is identical to this distance. Are we surprised? No, because it's a rectangle. Now, another type of parallelogram that we are to learn is the rhombus. The rhombus is special because it is a parallelogram that has all four sides the same length. This side equals that side, equals that side, equals that side in length. Now, what does that do for us? Well, first of all, since it is a parallelogram, it has all of the properties of a parallelogram. So, these two sides are parallel. These two sides are parallel. Opposite angles are the same. And diagonals bisect. But we also have another cool property with the diagonals in a rhombus. The diagonals are perpendicular. That means that these two lines are perpendicular to each other. And another cool property about rhombuses are that the diagonals bisect the angles perfectly. So this angle on top is the same as this angle on the bottom. So that is a parallelogram, a rectangle, and a rhombus. Now you may notice that I have left room for one more shape, and that is the square. What's cool about a square is that it shares the properties of a rectangle and of a rhombus. How is that true? We'll zoom in for you guys. A square is a shape that is a quadrilateral. It has four sides. All angles are 90 degrees. And all of the sides are the same. So it has all the properties of a parallelogram. It has all the properties of a rectangle. And all of the properties of a rhombus. So when you're doing your proofs problems and you see a square, you see a rectangle, or you see a rhombus, you want to remember these properties of them because they'll help you with your proofs. Now, one thing I do want to point out, which is very important, is that if you have a square, it is a rectangle. But not all rectangles are squares. All squares are rectangles. All rectangles are not squares. It's the same as if you have someone who goes to church all the time and someone who is following Jesus consistently. All people who are following Jesus consistently and love the Lord probably go to church. But not necessarily everyone who shows up in church is following Jesus every week. So you have to make sure that you are consistent and you're truthfully following the Lord, not just fitting into one of these categories sometimes, right? A little bit of fun there from the Bible. So, again, all squares are rectangles. All squares are also rhombuses, but not all rhombuses are squares. Not all rectangles are squares. So you have to watch out for that. And also watch out for those who believe one thing and say the other. But we'll leave that for a discussion in the Bible. Now, you will encounter some of these in your proofs, but the main problems from this lesson come from this shape called a trapezoid. A trapezoid is a quadrilateral, but it is not a parallelogram. Why is it not a parallelogram? Because it only has one set of parallel sides. Now, we can do some pretty cool problems with these. The first thing I want to share with you is the equation for the area of a trapezoid. The easiest way to find the area of a trapezoid is to average the bases and multiply by the height. You can prove this in a pretty easy way. Let's take a look. If you haven't already, write this on your equation sheet. So, in its simplest form, a trapezoid is two triangles. This triangle on top with base 2, and height h, and this triangle on the bottom with base 1 and height h. What's the area of the blue triangle? Well, the area of the trapezoid is area blue plus area red. The area of the blue triangle is base times height over 2. And the area of the red triangle is base times height over 2. In this case, base 1. If I add these together, I can factor out h over 2, and I'm left with base 1 plus base 2. Or, rewriting it, base 1 plus base 2, and take out the height. So that is your formula for area of a trapezoid. Inside of that, you notice the formula for the midpoint. So the other equation you need to know with trapezoids is the midpoint. It's quite simple. The midpoint is base 1 plus base 2 over 2. So average the two bases and you get the midpoint. Let's try an example. Here's a trapezoid with some numbers included and variables. And they want us to find the value of x. I remember from the midpoint formula that the midpoint is base 1 plus base 2 over 2. So color code these. We'll call the midpoint this one here, the one that goes down the middle. Base 1 we'll call the one on the bottom, although you could choose any one you want. And base 2 we'll call the one on the top. After that, you plug in and solve. The midpoint is 4x plus 1. Base 1 is 7x minus 2. Base 2 is 2x plus 2, all divided by 2. Solving, I can multiply by 2 on both sides. 8x plus 2 equals 7x minus 2 plus 2x plus 2. To solve, I'm going to move all of my x's to the left side. 7 plus 2 is 9. And I'll move my numbers to the other side, in this case, 2. So 8x minus 9x is negative x equals 7x goes away and 2x goes away. I have minus 2 plus 2 minus 2. That looks like minus 2. So x equals 2. And that, my friends, is problem set 33.